how do we couple the temperature of the underground with our heat pump and with our building. So this means to have to install some pipes in the underground. These pipes are typically plastic, and they're installed by means of drilling machines of different types of technology, depending on the type of underground we have, or recoverable casings, which sometimes are used to stabilize the borehole in order to avoid the collapse. Also, we have in Scandinavia and in north of Europe some types of systems that which the borehole is just filled with the water. This water is turned into ice and has a good conductivity. But these systems cannot be used in the south of Europe, where the temperature in the underground would prevent the water to form ice. We can also look at other typical questions which arise when we install a ground source heat pump system, like the need of doing trenching, excavations, or protecting our sensor circuits with whatever systems, or even monitoring our ground source or borehole heat exchanger in order to know what are the underground temperature and how the system is affecting the underground temperature. But we will go much more into the details of the installation of ground source heat pump systems in the future modules of our MOOC course. Shallow geothermal energy is almost invisible once the system is installed, as we can see here in the right bottom picture, which shows our test site at Valentia, in which there are many system installs that you don't even see once they are properly installed. Here, one important aspect when we are designing shallow geothermal systems is what kind of geology we have in our site, from 2 points of view. One is that so-called drillability, so how easy or difficult it is to drill that surface. Here you can see a map produced in the Geo4Civic project, in which different technologies for drilling, which were most appropriate in the different types of soil, were characterized. One fundamental aspect is the drilling cost. The other important and essential aspect is the conductivity, which depends critically on the type of ground we have from its conformation. There are regions in Europe with, like here in Spain, you can see, with a very broad range of different lithologies, which means that the conductivity of the underground is very different in the different parts of the country, whereas there are regions in which this situation is much more homogeneous, as you can see here in the north part of Germany or Denmark. So this type of map give us indication parameters that are essential for understanding the proper sizing and design of our actual system. If there's no sufficient information about this conductivity of these soil parameters of how or the most appropriate technology to install our shallow geothermal system, there is often the thermal response tests, which are the installation of an actual borehole heat exchanger, which is coupled to a device, like you can see in the left part of the picture, which injects actually heat into the underground during typically 72 hours or more, in order to study the response of the underground to this temperature injection. And here you can see results of such a TRT analysis, which allows to extract very useful parameters for the design of such systems. We will also cover TRT in our course in order to make you understand how and when they are useful, or in which conditions they can be avoided because of the extra cost that they may produce. Finally, there are important building-related aspects when we talk about the utilization of shallow geothermal energy, such as what is the building energy demand in terms of heating, cooling, how this demand is balanced, or how this thermal demand is structured across the year. If it is even or it is concentrated in certain months, this has a strong impact in the design of our system. Sometimes also shallow geothermal systems can be combined or hybridized with other types of technologies, and this is also part of the attractiveness of our shallow geothermal technology. I have covered some of the most important aspects or questions to be taken into account when standing and sizing such systems. But we will go much more in deep into the details of each of these aspects in our modules that will be covered by different experts in the different parts or areas of this technology. So thank you very much for your attention and enjoy the rest of our MOOC course on shallow geothermal energy.